Okay, so for our compound machine called the AMAwnster, because that was such a high ammo, that's a picture of our machine.
Our objective was to make a machine including 3 mechanisms that lifted a 1 kilogram weight, 12 inches, and we did so with a system of gears and pulleys.
Okay, so while planning our machine, we kind of wanted to make one design that was, where we didn't really care about weight, and it was just about getting highest ammo as possible. And then another one where it was kind of, didn't get that high of ammo, but it'd be pretty light. And while we were doing that, we kind of found this design, which was both light and also had a very high ammo. So that's kind of some of the sketches from original. The original design didn't really have a tower, but then we added that in. This is one where the gear actually went back on itself, and it would have had 12 iterations of the gears, but we ruled that one out because it would take way too long to lift the weight.
Some machines or mechanisms we used was a chain and sprocket gears, mesh gears, and wheel and axle. The mesh gears gives the machine a higher ammo, and the wheel and axle allows the gears to be compact. Some of the videos.
That's quite a bit. This is just slow pulling.
Yeah, you have a better look at the gears turning. So these are our calculations. We calculated our IMA by taking all the string it took to lift it 1 foot, which was 107 feet, and divided by our 1 foot, which is how far we had to raise it, is an IMA of 107. And then it took 9.8 newtons. It takes 9.8 newtons to lift the weight normally, and with our machine, you only have to pull with 0.2 newtons, which gives it an AMA of 49. We don't have it gives us a pretty low efficiency, but with all the gears and stuff, and we had one of the lowest weights at 2.2 pounds, which has a total price of $22,000. And then these are the individual calculations for all the gears and stuff. We didn't multiply them together to give us an IMA. Instead we did it the other way, because when we do it this way, it gives us an inaccurate answer. So now we'll demonstrate our machine. Wait, should you measure a foot before we start getting going?
Is it starting from the bottom?
Yeah,
or?
yeah, it's moving.
Oh, yeah. Well, I think it's probably going to go a foot. In the next year or so.
Ta-da.
Can you keep it going?
That's how it goes.
So can you lower it down a little bit? Whoa.
Okay, it doesn't go back any farther down.
Okay, all right, go ahead and go.
Okay.
All right, good job.